So welcome to this continuation of the module 1. Now we are going to discuss about pulverized coal burner. This also we called as sometimes furnaces. Pulverized coal furnaces or pulverized coal burners. So these devices that allow uniform mixing of the fuel and air, hence it leads the efficient and complete combustion. So the burner when receives the fuel along with the primary air in a central passage, and while secondary passage secondary air is going to be received. So a good design of the burner is essential to achieve complete combustion of the fuel. So thus a good burner should meet some essential requirement for the uh, design of the burner. So let us discuss some of the points for the burner. First, it should have mix the fuel primary air thoroughly and inject the mixture into the furnace, and it should create proper turbulence for the air fuel mixing and maintain the stable combustion, and it also should able to control the flame shape and flame travel by varying amount of secondary air. So and also cold air mixture should have moved away from the burner at the rate of equal flame size level to also avoid the flash back. So it should project it properly to avoid overheating and wear the internal fires. So let us see different types of burners are available. So there are four types of burners under the pulverized fuel burning. First one is long flame or U flame, also called a streamlined burner. And second one is short flame or turbulent burner, and third one tangential burner, and fourth one is cyclone burner. So let us discuss one by one. So this is a long flame or U flame or streamlined burner. Why it is called long flame or U flame? So because the arrangement is like that only, because while the flame is taking in the shape of U and it is a very long kind of flame, hence we call it as a long flame or U flame type of burner. So the U-shaped burner is schematically already shown, and the burner is placed such a that it produces a long and U-shaped flame, and burner injects a mixture of primary air and fuel vertically towards the thin streams practically within no turbulence and produces a long flame. Hence we call it as long flame or U flame. Okay, so this is how we can see. And secondary hot air is supplied at angles to the flame, which provides necessary turbulence for mixing proper and rapid combustion. A tertiary air is supplied around the burner for better mixing of the fuel with the air. In this burner, due to the long flame travel, the high volatile coals can burn easily, and the velocity of air and mixture will be at the burner tip is around 25 to 30 meter per second. You can see the short flame burner. This is a long flame burner, this one, and this is a short flame burner. Why we call it short burner? The length of the travel, that is flame, is very short, hence we call it a short flame burner, and it is a very long and it is U shape. Here U shape we call it as U shape burner, U flame type of burner. So in case of short flame burner, what happened? The turbulence of occurs in this case, and these burners are generally built into a furnace wall so that the flame is projected horizontally into the furnace. So you can see the projection of this burner are horizontal. Okay, so this is horizontal. Okay, you can see the projected horizontally into the furnace, and primary and fuel mixture, it combines with the secondary air at the burner periphery before the entry into the furnace, as shown in the figure, as we see in the figure. So the burner gives out the turbulent mixture which burns rapidly, with combustion is completed within the short distance. Therefore combustion rate is high, and the velocity mixture of the burner tip is about 50 meter per second to 55 or to 60 meter per Second, so in such burners, the bituminous coal cannot be burnt easily because forms cake. So it is very difficult to burn. So modern high pressure capacitor power plants are used for such kind of burners. So next one we can see tangential burner. So this one we call it as tangential burner. Why we call it as tangential? So this burner are built into furnace walls at the corners. So inject the air fuel mixture tangentially to the imaginary circle into the center of the furnace. So as the flames interrupt, it leads to this swirling action. So due to the arrangement at the uh, corner of the burner, what happened? So it adjacent side of the uh, form created by the tangential burners, so it creates swirling. So as the flames interrupts, it leads to this swirling action. So this produces sufficient turbulence in this furnace for the complete combustion. Hence such a burner, there is no need of produce high turbulence within the burners. So this is about the tangential burner, and it gives fast and high heat release rates and avoiding fly flash problems, and which is common in other types of burners. And this burners used crushed coal, that is around 5 to 6 of size instead of pulverized coal. So this burner can easily burn low grade coal with high ash and moisture content. Also it can be burnt biofuel such as a rice husk, okay, where the farmer having paddy is available, the rice husk will get it, so that also we can use. And the principle of operation of cyclone burner uh, we'll discuss in the next video. So next one is the principle of cyclone burner. So cyclone burner, why we call it as cyclone burner? So this cyclone burner consists of horizontal cylinder about 3 meter diameter and 4 meter length. So the cylinder wall is water cooled, and while instead of surface is lined, so the chrome core, okay, the horizontal axis of the burner is slightly inclined towards the boiler. The coal is used for cyclone burner is crushed about 6 size. And coal and primary air is about 25% of combustion, and secondary air so are admitted tangentially into the cylinder. So as produces strong centrifugal motion and turbulence to the coal particles, so cyclone kind of formation will be taking place. So the high velocity about 100 meter per second, and the tertiary air is about 5 to 10% of the secondary air is going to be admitted, and axially at the center already we have shown in the figure. So such burners are produced high heat and temperatures around 1000 degrees centigrade, and due to this high temperature burning, the ash melts in the form of slag, and it is drained out periodically at the bottom. So this is about the so some advantages of cyclone burners will discuss. Since it is uses crushed coal, it saves the cost of pulverization. So all incombustible are retained in a cyclone burner, and hence the boiler fouling problems are reduced. And it requires less excess air as it is uses forced draft, and slag recovery is around 80%, and dust passing to the slag is about 10%. So thus the equipment can be used for the dust removal, and fly ash problem is reduced to great extent. Low grade fuel can also be used. What is the disadvantage is that it is a high pressure draft and consumes high power, and it produces more oxidize and creates the atmospheric pollution. So this is all about the cyclone burner. So we'll discuss other points in the next video.